Hello and welcome to the Daily Space for today, September 26th, 2018. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. Today, I'm going to be reviewing some of the top stories coming out of astronomy and space science, and then I will be taking your questions. Following this roughly 30-minute episode, I will be handing this stream over to Dr. Matt Richardson, and he will be teaching Astro 101. So get ready, the science is coming. In today's top story, we have word that the Chandra X-ray Observatory is going to be able to continue its mission into the future. Each spacecraft is given a set amount of time that it is funded for, that its operational procedures are contracted for, and every few years it has to undergo a review process to determine if the spacecraft is still, worth how much money it costs to run it. Each of these telescopes requires a fair amount of infrastructure. With Chandra, you have to have a group of people controlling the telescope, sending it up information on what objects it should be pointing at, getting the data down, getting that data out to the scientists. And speaking of the scientists, you have to have an entire infrastructure that is working. We have zombies on the screen. I'm not sure why we have zombies today, but I will not object to zombies on the screen. Anyways, returning to Chandra. Speaking of those scientists, we have to have a team of people that go through, receive all of their requests, their proposals for observations, that pull together groups of professional scientists to review those applications and decide whose observational plans are the ones that are going to get to be used by the spacecraft. Chandra first launched back in 1999. This is, a 19-year-old spacecraft. It's one of NASA's great observatories, and it is out there observing the sky, in X-ray radiation. And it is returning to us understandings of where there are black holes, where there are supermassive galaxy clusters. And the science just keeps coming. And with our newest announcements, we find out that, the science gets to keep on coming, perhaps as far as September 30th, 2030. In the current funding cycle, NASA has extended its contract with the Smithsonian Astronomical Observatory, which is in Cambridge, Massachusetts, part of, it's physically co-located with Harvard College Observatory at Harvard University. And these facilities will be funded through September 30th, 2024, with two possibilities for 3-year extensions. So this is great news for all of us who know there isn't another, similar spacecraft in the pipeline to bring us data in the future. So we get to keep using our favored, space-based observer. Now, continuing on to our next story, we continue to explore our high-energy universe. In this case, we're looking at a neutron star that is behaving in ways that we didn't know that they could behave. Neutron stars are the leftover remnants of massive stars that have ceased to produce new energy through nuclear reactions in their core, and when these nuclear reactions stop, they stop generating massive amounts of light that is out there otherwise supporting the outer atmospheres of the star that gravity is trying to crush inward. When that outward pressure from the light stops, the star collapses, massive nuclear reactions occur, the entire thing explodes as a supernova, and in some cases you end up left over the core of that star. This is an object that is roughly the diameter of Manhattan Island and is, more than the mass of the sun. It is, these are amazing objects. And in some cases, they have amazing magnetic fields of their own. back in 2005, one of these objects, its nuclear field realigned itself and generated a pulse of gamma rays that we detected through the sides of spacecraft here at the planet Earth, even though that object was on the other side of our galaxy's core. Anyways, when these objects have their own powerful magnetic field, it was generally thought that the disk of material that surrounds the neutron star would be unable to generate its own concentrated magnetic field that could drive a jet of material. In some cases, previously only seen with low magnetic field stars, the disk of material that sometimes exists around a neutron star, this is material that has been gravitationally stolen from another nearby companion star. This disk of hot ionized material, as it orbits, generates a magnetic field, and this magnetic field from the disk is capable of jettisoning particles in powerful jets that we can see at great distances. These jets are visible in the radio. Now, since the jet is generated by a magnetic field associated with the disk of material, when a star has a powerful magnetic field, if it prevents the disk from having its own powerful magnetic field, you get no jet. Now, what was seen here was a star with a powerful magnetic field and a disk with a not very powerful jet. And this was the first time we'd seen this particular, combination of things in the sky. And it's being thought that what is happening is the magnetic field from the neutron star is actually coupling with that disk, generating the magnetic field in the disk, and it is still the disk magnetic field creating the jet. It's just the star that's creating that disk's magnetic field. And if that sounds convoluted, that's because magnetic fields are hard to understand, and it is convoluted. But one way that you can think about this is if you have a powerful magnet on hand, you know that, if you attach the powerful magnet to some metallic object, over time, that powerful magnet will generate a magnetic field in that object. Many women, for instance, will keep a magnet stored on their sewing scissors so that their scissors become a magnet that can be used to pick up needles while sewing. In this case, that neutron star played the role of that sewing box magnet. And that disk, it's not so much collecting the needles as it's flinging particles at high velocities in this not very powerful jet. So new cool science, a new way to study magnetic fields, and a new thing that theorists have to take into account as they try and explain how it is that accretion disks, their magnetic fields, jets, and the magnetic fields of neutron stars all shape the universe. Now, coming back a little bit closer to home, I have an object that is very hard to see in this NASA image, and I'm going to live dangerously and attempt to full screen this, except I full screen something else. Okay, so I can't full screen this at the moment. Going back to the image I was on, you can see there's a bright ridge in this image of Mars. This is the edge of a crater. And if you follow down this ridge and drop down a little bit, right here where my cursor is circling is a little tiny spot. Let me see if I can zoom in on this at all. That little tiny spot right here in the image, centered in this image, kind of centered in this image. That little spot, that is Mars Exploration Rover Opportunity. As you know, there was a terrible dust storm on Mars, and we last heard from Opportunity Rover back on June 11th. ever since then, it's been, we hope, in a shutdown mode that allows it to conserve power and nonetheless keep itself warm enough that when the sun comes out, when it is able to once again gather more electricity using its solar panels, it will be able to turn itself all the way back on and send, well, a signal back to us here on Earth. At this point, we still haven't heard anything from this little rover, and we don't know when we might hear something from this little rover. But the HiRISE instrument orbiting up above is peering down and letting us see that our little rover is at least not completely buried. We had no belief it would ever be completely buried. That was not something we were worried about. But it's still nice to get to look at our little rover. So, yeah, we can see the rover, and now we're in the middle of this period of time during which the Mars Exploration Rover team out at the Jet Propulsion Lab in California is every day using NASA's big ear to send messages out to Opportunity, asking it to please respond to the commands they're sending. We are hoping that during this 45-day period, we will hear back from the spacecraft. Now, we have a couple of concerns. The first is that this rover, while not buried in dust, might have enough dust settled down on its solar panels that it's just not able to charge its batteries enough to signal home. In this case, we're all waiting and hoping for a dust devil to come along and, as has happened in the past, well, do its dust devil thing, gust wind, and blow that dust off of the Opportunity rover, allowing it to catch some more light. We are also just concerned that something happened during the storm and somehow damaged the little spacecraft. At the end of the 45-day active signaling period, the folks at JPL will contact NASA headquarters in Washington, D.C. and ask, what do we do next? And it's unclear if we're going to be able to continue the active signaling process, or if instead, due to funding concerns and just not knowing if it's worthwhile, if we'll instead have to enter a passive listening period where instead we simply use our Earth-based antennas to listen closely and otherwise not invest efforts in trying to get this robot functional until it calls home. Now, even if we do hear from Opportunity, NASA is making it quite clear in its announcements about this project that there could still be reasons that we can't operate the rover, that something did happen to it. But as we know from Spirit, when Spirit got initially stuck in the dust, we were able to find interesting scientific questions it could still answer. So here's to hoping that we get Opportunity back. We can see it. It's there. And phone home, Opportunity. We really want you to just phone home. So moving on to today's next story. This one came from an unexpected place. In a tweet, Thomas Zurbuchen, the current NASA Associate Administrator, announced that, well, NASA, let me just go ahead and read this tweet. As part of its efforts to search for extraterrestrial intelligence, we're, in this case referring to NASA headquarters, hosting the NASA Techno-Signatures Workshop in Houston, September 26th through the 28th, to assess the current state of the field, the most promising avenues of research in techno-signatures, and where investments could be made to advance the science. What he's talking about is NASA's plans to put together teams of researchers that are trying to understand not just the biological signatures that we might be able to detect of worlds that have life, but also the technological signatures that are indicative of an advanced civilization. So NASA in recent years has gone from we are not looking for life to yes, we are looking for life in all its different possibilities of being discovered. So I don't know what we're going to find. I don't know if we'll find it in our lifetimes or how. But I remain ever hopeful that in the coming decades, I don't think we'll be able to detect a civilization, but I do think we will begin to detect the biological signatures that there's something else out there, whether it be plants or methanogens or something else. It's an awful lot of space that's wasted, to misquote Carl Sagan, if we're the only life out here. Anyways, those are today's top stories, and I am now here to take your questions. So if you can please at me in the chat, it would be greatly appreciated so that I can find your questions quicker. I see that Hanny is already asking, will the Rover scientists just move over to Curiosity or Mars 2020? Not all of them. The truth is that Mars 2020 has a set amount of budget. It's already allocated. It's already staffed. Mars Curiosity already has a certain budget. It already has a staff. There are Mars rovers drivers. There are people working on Opportunity that is their source of funding. This means when the spacecraft dies, there are people that could lose their jobs. And this is one of the hardest parts of space exploration and the loss of missions. Yeah, these are things that break my heart. Scrolling back, looking to see other questions. I don't see any. I do, however, see Bad Panda with his, "Hi, Opie, wake up." I agree with you so much, Bad Panda Bear. Opie needs to just wake up and call home. So Henny is also asking, is it possible to detect massive amounts of farming? See the effects in the atmosphere. I'm not sure if we can so much detect agriculture. Thank you so much for the bits. Can we get some rockets lighting up the chat? I'm not sure. I'm not sure we have the capability to detect the difference between a planet that has agriculture and a planet that has just plants being plants, unless what we're actually detecting is the use of fertilizers, the use of, petroleum products to power our vehicles, the coal. I think it's all the things that go with advanced civilization that would allow us to differentiate. That's a world with plants, and that's a world with life that is probably farming. So Graham is saying SETI seems to have detected more signals by using AI. So far, SETI has detected all sorts of radio signals coming from interesting objects that are doing scientifically interesting, not life-related things using their detectors. And yes, it is often various forms of neural networks and other things that is allowing these detections to be made. But the reason that the neural networks and the other algorithms that are being used are able to find these things is they've been coded to look for certain kinds of behaviors in the signals they're looking at. As we move into the brave new future of directly measuring what is in the atmospheres of other planets orbiting other stars, we're going to be able to code those algorithms to, instead of looking for periodic radio signals, to instead look for specific chemical signatures that have to be defined by scientists. Otherwise, we can't look for them. Now we're also trying to figure out what kinds of signals do we program the software to look for that are technology-based. So at the end of the day, yeah, we find things using artificial intelligence, using advanced algorithms, but we have to tell those algorithms what to look for. looking to see what else is out there. So Kay Moore is asking, is it worth more to let opportunity rest in peace and to send that money to other projects? I don't know, Kay Moore. That's a hard question. Thank you so much, Guido. Light those rockets up. Thank you, Guido. So robots are expensive. Opportunity is in a place where we don't have any other on-the-ground technology to measure. It is in an amazing landscape. It costs more to produce than it costs to maintain. And so it is, in the long run, cheaper to use the existing technology as long as we possibly can than it is to build new robots. And at a certain point, you want to get robots out exploring as much of Mars as you possibly can. And here you're talking about budgets where we use the B word, billion, to describe their budgets. Where we're looking at maintaining a rover that's already there, it's a budget in the millions. And so I'm not sure. I'm not sure it's a small enough amount of money, given the fullness of the budget, that it's better to just let the robot go. Now, all that said, we are looking toward having a funding crunch. The James Webb Space Telescope didn't launch. It still has construction costs. A spacecraft is never more expensive than when it's on the ground. And in order to fund its continued not launched state, NASA's going to have to find continued funding to fund its not yet launched state. And NASA's total budget is flat, so that extra money has to come from somewhere. And so we know there's going to have to be cuts. And so someone who is thankfully not me, because I wouldn't want to have that resting on me, someone who isn't me is going to have to decide, is it Mars Exploration Rover that gets defunded? Is it CosmoQuest that gets defunded? Is it some project I haven't thought of? We're all in jeopardy. We're all always in jeopardy. And we have to constantly prove ourselves as being scientifically worthwhile to our peers who review us each year. So luckily, I'm not the one to make these decisions, because I don't want to be the one to make these decisions. Thank you, Trucker Kev. Zombies on Mars. Well, we have zombie robots on Mars. We don't have actual human zombies on Mars. River operations. I'm not sure what river operations. You mean Rover. And this is the thing, is we do sometimes allow spacecraft to go from one place to another. The WISE mission has been handed off a few different times. And yes, more with the rockets in the chat. So there's always different possibilities. So I see Hanny is asking, how long does an accretion disk last around a newly formed neutron star? Well, it depends on how long it can steal material from its companion. If it has a nice big a nice big plasma-y companion star, we're looking at millions, maybe even billions of years that it just slowly draws things out. This is the kind of thing that I'm sure people have modeled. I don't have the exact number in my head, but it literally comes down to how big is its companion star, how close is its companion star, and what is the rate at which it draws off material. So, yeah. And Guido, autocorrect happens. I was able to figure that one out. So yeah, Hanny, the United States does launch a ton of rockets, but not all of our rockets are ones that are NASA-funded stuff and things. Most of the rockets are launched from NASA-funded facilities that are overseen by the various agencies. But these launches cost money. Use of the launch pads cost money to hopefully cover a lot of these costs. And we have commercially built rockets. So here, even the Delta II is made by a non-governmental agency. Boeing, General Dynamics built spacecrafts, Boeing, Lockheed, all these different companies that build the rockets, SpaceX. They are paying for the facilities they use, and then quite often it's companies like AT&T that are in part or in full paying for that launch to get their communication satellites, their weather satellites, all these different non-scientific satellites into orbit. So yeah, we launch a whole lot, but a whole lot of it isn't dedicated to doing science. Anyways, that's today's news. And I know that we are just a couple of minutes away from Dr. Matt coming in to do Astro 101. I would like to thank you all so much for all the support today. That means the world to us. This show is a joint production Society of the Pacific, like me, the Planetary Science Institute, that's Dr. Matt, and Youngstown State University, where we have Annie, who is here for Science Sundays on Sundays. I will be back tomorrow, and Friday we will have Dr. Andreas Plazas coming to do the Daily Space. Tomorrow night we will have an episode of Learning Space at 9 p.m. Eastern, 11 a.m. Sydney, Australia, 6 p.m. Vancouver, Los Angeles, otherwise known as the Pacific Time Zone. Tune in, and we are going to have a amazing person, Jose, who I forgot his last name. I'm so sorry. He's going to be coming and talking to us about a visual experience that takes them into the stars. So stay tuned and give us a follow and get notified every time we go live. And as always, we are supported through your subscriptions and your bits. Everything helps. And I will see you on the other side, wherever in the world you may be. Have a fabulous morning, evening, or afternoon. And remember, get outside and look up. Bye-bye.